Right, I'll relate the last type of reactions where the reactions of alcohols. Now we have reactions of alcohols, meaning alcohol now will be a reactant, no longer the product, but will be the reactant. Right, let's start from here to be number one. So alcohol, we can have alcohol as a reactant, but we can undergo an elimination. So if you are doing elimination, having alcohol as a reactant, then we're going to have a product being alkene, because every elimination we're going to have a double bond or alkene as a product. So that is the key. When we see a product as an alkene, it means we had an elimination. So it might be cracking or just normal elimination. So right, let's check the first one. This is our alcohol here because of OH bonded to a carbon, then that will be an alcohol. So if you see OH bonded to carbon, then it is an alcohol. As long as there is only single OH bonded to a carbon, then that will no longer be alcohol. For alcohol, we need only one oxygen bonded to hydrogen, and those OH must be bonded to a carbon, then that will be an alcohol. Right, having this alcohol, now this alcohol decompose with help this reaction condition of sulfuric acid, which is a strong acid. So reaction condition yona or lemo eliminator, then we have an addition of H2SO4 as a catalyst, and we're going to have heat. We need heat to separate these things. So what are we going to remove? Because we're doing elimination from alcohol, it means we're going to remove an OH because we're from the alcohol. Then the remove OH, obviously one of the hydrogen, because I remove the carbon here, remove only the substituent, we mean remove the bond to the carbons. So remove OH, then they must follow a hydrogen. So we're still using our Markov-Nikov's rule, modeling for us to have the major product. So le carbon o bond le hydrogen tse dinnyane ka ntle le o a tshwareng le OH. So re mo lebeletse mo wa mathomo o na le 3, wa mafelelo o na le 3, but wa gausi le OH o ra na le only 2, then re tlo remove the second one. On the second one, remove hydrogen there. Then I remove or formula a major product. Hence running carbon number, I'll give name again 1, 2, 3, and 4. So carbon number 2 and 3, a double bond. This is 1, 2, 3, and 4. So that is why they share a double bond more. Then I remove the OH and then I remove the hydrogen. Now me up OH minus, then hydrogen plus. So rather than remove then they are going to bond together and then they'll form H2O. So they'll form this part now. And then I deform this one. So more canoring this part as O bonded to H. Then now that's why we can write it like this here. So now that's what is produced there. Then here, this one, they said OR, meaning this is a minor product. But the question will specify for the major product. If you ever specify, always write the major product using the Markov-Nikov's rule, where it say you must get removed from the carbon with the least number of hydrogen atoms. Right, related conditions must have that, and then the type of elimination, we call it dehydration. So dehydration means we are removing water, so we'll make this dry. So that's why we have that. Reactants, we're going to have alcohol, and then with H2SO4 as a catalyst. Now if you reactor is a catalyst, of course you do not just format the part of the product, because in about tusha this compound or separate products. We can have we have alkenes and H2O. H2O is a must because we are removing OH and hydrogen. Right, this is what we have for first one. Number two, we have a reaction of alcohols, which giving us a substitution reaction. But this substitution reaction will become, we have a reactant of alcohol, and the product will be a haloalkane. So what we're going to like one, this is the hydroxide, ye bontsha now renal alcohol here, plus namile e reacta le hydrohalogenation, which is H bonded to Br. That is hydrohalogenation. So if alcohol reactor to hydrohalogenation, then we are going to make a substitution, but under conditions of heat. So essentially heat more. Then more the reaction here, we're going to have condition heat. I mean, there's no heat at this system. I mean, because we're saying substitution, hydrogen is positive, then bromine is negative. Then meaning that if substitution running OH minus ki negative, running one negative would change channel one negative. Hence OH minus more mele Br, change Br. But then ora Br o la bjale mo o se pitse o tlile OH o sa jatle mo a etla mo, then or OH what change the position now, OH you to bond H, then they form water. Then other form of water, which is this one. Namile, the reactions needed is alcohol and then hydrohalogenation. The primary and secondary alcohols, which it means they can do the same thing. Then NABR plus H2SO4 used to make HBr in the reaction flask. There's no what about that. Tertiary alcohols, HBr or HCl directly. So that if you are going to form a tertiary alcohol, then you're going to react with HBr or HCl. Then for primary and secondary alcohol, what are the react NABR with or HBr in reactant flask. So but this H2SO4, it can also be there, but to be as a catalyst, but it also going to be in a flask. So the products haloalkane plus H2O, because we're not eliminating, then the product will still remain alkane. So that's why you have haloalkane plus H2O. Right, the last one, we have the esterification, where acid catalyzed condensation. So the alcohol, esterification over alcohol reacts with carboxylic acid. Right, then this is the alcohol, this is the carboxylic acid. So So what do you have? And then now uh, quickly out of battery here. Right, how do you join these two? We're just going to write the number of carbons. How many carbons are here? 1, 2, 3, 4. There are 4. So we're going to say 1, 2, 3, 4. Namile check more acid kichikae. Acid is no longer alcohol because in oxygen that would be acid. 1, 2. So rabale 1, 1, 2. Namile di orange again. This acid and this one is orange again. Oxygen here. Namile di orange oxygen more. What is left running? The one out from the acid, another oxygen near the double bond. And then from there, that's what we have. And then we're going to have H2O here. And then the products will be ester and water.